I'm Sten Mander from Casa Grande High School, and this is the bike generator. What we have here is a 21-speed mountain bike by Specialized, and a specially designed dashboard and a generator. Let's start in the back. This generator came from a treadmill. It's made by Pacific Scientific, and it's 135 volts DC at about 18 amps. We're not going to get anywhere near there because we're just doing it with a bicycle. So how it works is you're going to be riding, or I'm going to be riding, and the back wheel, as you can see, rides directly on the flywheel of the motor. This motor from a treadmill, if you turn it with a bicycle, will produce up to 30 volts. And let me show you how it works. Connected to the motor is this black cord, which comes all the way up here to the control panel. And what you do is you get up on the bike like this and start pedaling. Energy from my food, which originally came from plants, we got their energy from the sun, is converted into mechanical energy as I'm pedaling. The bike turns the generator makes electricity. On this control panel you can see we have two DVMs. The left one we're going to use to measure volts, and the right one we're going to use to measure amperes. So let's get started. First you want to set the voltmeter to the 200 volt DC range. Then you want to set the ampere meter to the 10 amps DC range. The first thing we're going to do is we're going to connect the voltmeter across the generator terminals. Take two cables, one in the red and one in the black generator terminals. Then we're going to plug in the other ends of the cables. Black goes to COM on the voltmeter, and red goes to volts, ohms, and milliamps. Just like that. So we're going to start pedaling. When we're pedaling, we're converting. We can turn it off so you can see. First it's nothing. Start pedaling, turn on the switch, and you can see we're making about 20 volts. Next I'm going to make a bulb shine. Let's start with bulb number 1. I'm going to take two more cables. Let's turn the switch off again. Take two more cables, plug them into the generator terminals by stacking the plugs. Then we're going to take the black one and put it across bulb 1 in black. And the right one, again, across bulb 1 in right. Now we're ready to pedal. So pedaling, turn on the switch, and now we're putting about 18 volts across bulb 1. Now we're going to see how much current is flowing. Turn the switch off. Take the stacked plugs out of the red and put them in the COM terminal of the ammeter. Last step is you take a single cable, plug it into 10 amps DC, and the other end goes into the positive terminal of the generator. Now let's try it. Start pedaling, get it going, turn the switch on, and what you'll see is we have about 40.45 amps, about a half an amp of current, and the voltage is, if you can to the voltage side, about 20 volts. So we're making 20 times a half, about 10 watts across that bulb. Let's try the next bulb. turn the switch off, unplug the two cables that were across bulb 1, and let's put them across bulb 2. Black and red. We're measuring the voltage across bulb 2. Notice bulb 2 is bigger. Let's check it out. Turn on the switch. Now we're doing about 10 volts. But now we have 1.35 amps of current. So that's about 20 watts. Notice it's brighter, bulb bigger. So we'll turn it off. Let's check bulb 3. Unplug the two cables that were across bulb 2. Go to bulb 3. Left one goes to the black. Right one goes to the red. We're measuring the voltage across bulb 3. Switch is off. Let's start, get it spinning. Now this is much more difficult to turn. So I have to speed up a little to get my 10 volts like last time. 10 volts, almost 2 amps. So that's about 20 watts. A little less. And there we go. Okay, in this segment I'd like to explain how to get on the bike and get off the bike and set up the seat for people with different heights. This is a quick release lever for the seat. For shorter people, you go down there. For taller people, a little higher. And then make sure when you tighten it that the handle is pointing down so it doesn't poke you when you're pedaling. I like to stand behind the bike and make sure that the seat is straight. Now to get on the bike, it's okay to step on the platform. Here it says step okay. So step up on the platform, hold onto the bars, step over onto the wood. Okay? Notice my whole weight's on the wood and on the seat. I'm not putting a lot of force on the bars. We don't want to break it. So when you're ready, put a gentle force on the bars and get your feet on the pedals and start pedaling. Now there are a number of different gears for this bike, 21 in all. So if it's too hard for you, you can click down one gear by pressing this big lever. Make it easier. Make it easier. As the numbers get smaller, it's easier to pedal. To make it a little bit more difficult, take your index finger and lift up. You have to be pedaling the whole time to do this. Lift up. Every time you lift up, it changes gear. I happen to like 7th gear in the middle chain ring best. So I'm on 7th gear, which means the smallest sprocket in the back, and I'm on the middle chain ring in the front. So let's show you a little bit what how gear affects the performance. It would help if I hooked up the generator first. So, left to the generator on the black, right to the red, and then you can see the bulb shines. Now I'm going to hook up the generator's voltmeter, stacking the plugs, stacking the plug for the minus. I'll take the ends of the cables, black to common, red to volts, and let's start. Switch off, get the generator turning, and then now as soon as you turn that switch on, you can really feel the current is causing the generator to be more and more difficult to turn. So I can get up to 10 volts in this gear. If I were to jump to the higher chain ring, okay, now I'm on the higher chain ring. Now the whole thing is spinning faster. In the higher chain ring, I can get up to 20. I can get about 20 volts out of this big bowl. Let's check the current. So I'm going to hook up the ammeter, move the move the red terminal to common, take an additional cable between 10 amps and positive, switch off. So let's get it started. Sure is easy to turn now. As soon as I connect the load, however, it becomes much more difficult to turn. Now I'm doing about 30 watts. 15 volts, 2.3 amps. At maximum, this is the same power as one fluorescent light that we have in the ceiling of the classroom. And I'm pretty much going full out. Now that we realize how much effort this takes, this amount of effort, full on, is the amount of power one fluorescent lamp requires. One. And there are literally dozens of fluorescent lamps in this ceiling. So, this is to show you that it takes a lot of energy to make electricity. And that's the purpose of this lab. I'm Sten Mander from Casa Grande High School, and I'll see you next time.